Hey guys, sorry I'm speaking. George Walker Primitive. Kind of been wanting to go over this video for quite some time, for a few years. I know I touched on it a long time ago, about 3 years ago when I first started making videos. I never really done much, but wanted to go over compasses and using a compass for navigation. Now this is a beginner's navigation or beginner's compass video, and I'm going to be doing a couple stages, walking into a few different areas. So if you're familiar with the compass and whatnot, by all means don't watch my video. It's not going to hurt my feelings. But if you never touched a compass or shady on a compass, it's been 60 years or whatever since you touched one, or you need a refresher, by all means pay attention, especially if you have never touched one and you want to put one in your kit, or if you have one in your kit and you don't know how to use it. Okay, I will say first off, you're going to see these compasses are pointing in all different directions. Compasses are always supposed to point north, and they always do point north. Okay, but these are magnetic compasses. The reason they're all different directions is because I'm on my kitchen table and there's metal underneath it, and we'll discuss how metal interferes with compasses in a bit in the future here. But right now I just want to give you a little bit of familiarization with a compass and go over a few terms that we'll be using, and each video is going to gradually work its way up to a more advanced knowledge and usage. But right now I want to go over the different types of compasses. And of course, we all see these a lot, especially in EDC kits. These little bubble compasses, and these compasses are great. I mean, they're not great, but they're good. A working compass is always going to point north. It's magnetic, so it works on the magnetic fields of the Earth. One thing I will say, if you are shopping for compasses, and you go to a store and they have, say, 10 different compasses of these, and you can open them up and set them. What I usually do is I'll open them up and set them on the floor, on the concrete and tile floor, a couple inches apart from each other, to see if they all point one direction. If all of them are pointing one direction and one of them's pointing that way, I know not to buy the one that goes that way. That's just a little trick, a little caution to use. But they do work on the magnetic field of the Earth. So that's why it's called magnetic north when you look at a compass, so that's how you get your bearing using a compass. Obviously the needle is going to point to the north, and they're always going to be marked. Almost every compass is marked in the same way. An arrow is always going to point to the north. Okay, that's the common thing on all compasses. You'll never see a compass that has an arrow pointing east. And if you do see one that has the arrow pointing east, then that's, I don't know what that company is thinking. But the arrow is supposed to point north. And you have north, south, east, and west. And you see this one says southwest, southeast, northeast, just in case you couldn't figure that out on your own. Some of them glow in the dark, some of them don't, so keep that in mind when you choose one. Obviously if you want to navigate at night, you'll want something that has luminescent that can glow in the dark. But a little bit more about these button compasses. Okay, first off, you see these things only give, one, they're small, okay, and you'll understand the difference of small and large compasses as we talk about the bigger ones. But all these give you is a direction, the cardinal directions, north, south, east, west. It doesn't tell you degrees. All it does is give you cardinal directions. And you will see too that these are magnetic instruments, so just them getting near themselves will disrupt. Okay, as you can see how it's affecting the big one's affecting the little one. All right. But for getting general bearing, as you can see, this is one that's meant to be on like a keychain, which I think is kind of silly because its keys are made out of metal, but on some kind of zipper pull or something like that. I took it off since, but this is the one I carry on my EDC, just to have on me in my pocket in case I lose my main one in my kit. At least I can pick this up and get my bearing, and that's all you're really going to get when this is a bearing. And the bearing is the direction you're heading, okay, or knowing where. Getting your bearing is figuring out from where you're standing where's north, east, south, and west. Okay, and that's half the battle of navigating, is finding out your bearing. Okay, so if you're out in the middle of the woods or out in the dark or in the desert somewhere, and you're like, oh, I don't know where, I've lost my bearing. What that means is you don't know what direction you're heading. Okay, or what direction north, south, east, and west is. And that's what these are good for whipping them out and getting your bearing. Okay, cool, I know that's north, I know that's south, east, and west. Okay, so that's what your bearing is. And so these compasses are good, like I said, just for picking out and say, okay, I know I'm traveling north, I'm supposed to be traveling north. Okay, cool. I'm going the right direction. Oh, nope, I'm veering off my course. I need to go that direction a little bit more. Alright, now you see different kinds of survival compasses, and they come in all shapes and sizes. Every company wants to make their own. This one here is one I've seen quite a bit, and I've seen some people do videos and they show it, and I say, oh, I got my compass here, and okay, now this does have degrees on it, but you can't go by that, okay? Because the compass moves, okay? And those numbers have to move with the compass. They either have to move with the compass, or you have to be able to change the dial. Alright, so you can't pick this up and look at where it's pointing and say, oh, okay, cool, I'm going at degrees, because you can't move those numbers. When the north-seeking arrow moves, these numbers move along with it. Okay? If I'm looking, see right now the north arrow is pointing to the number 30, which is supposed to be 30 degrees, okay? But north is 0, okay? North is 0 degrees. So if you were to pick up something like this and just hold it up and go, oh, I'm going this direction, you're not going that direction. And you'll see when I discuss the ones that don't have a free-floating bevel or bezel what I'm talking about. But one thing I want to point out about this one, this is a survival tool, all right, which has a metal object inside of it. Okay, now I want you to watch that compass as I put the tool inside and out. Alright, you see that? Obviously this tool is magnetic and it's messing with the magnetic compass. Alright, so if you were to say, oh, I want to get my bearing, and you whip this out and said, okay, north is that way. No, it's not that way, because if you take out the tool, north is that way. Okay, remember what I told you, metal objects will affect this. Some compasses are very sensitive, some are not. So you can see as I put this back in there how magnetic north, which is that way, facing into my living room, now magnetic north is facing back into my kitchen. Okay, so keep that in mind, especially when you have your gear. If you pull your compass out, look at your gear, and you have gear on you and you have metal objects in front of you, or you have your compass attached to something metal, it's going to mess with your compass. I've seen a lot of guys in the Army doing their land navigation courses, and they were messing up. And the reason they were messing up was because they'd have their weapon strapped to the front of them. All the weapon's metal, and they would pull out their compass and be sitting there resting on their weapon. So you have to pay attention, and you have to be careful where you have the compass near and what you have it near, because it will change. So that's enough on the button compasses. Like I said, those are just for getting your bearing. They will serve the purpose of telling you north, south, east, and west if you don't have it near any metal. Now there's two other types, well, three here, but the other two I want to talk about, this one here does not have a free-floating bezel. This is the bezel ring. That's what has the degrees on it, okay? It has the north-seeking arrow, which will always face north, which is that way. Okay? You can see, but I don't know if you can see that. You can see on, this is my wood metal table, and the metal supports underneath the table are enough to mess with that compass. Okay, the closer I get it to this metal, and that's going through wood. Okay, this is solid wood table. So that's how sensitive a compass is around metal. That's why it's important to be careful of what you have near your compass, or when you pull your compass out, what you have on your body and around your body. Okay. But this is the bezel, and that's what has the degrees on it. This particular brand of compass, I know in most of my videos I don't push certain brands, but for compasses it's kind of important. Silva Polaris makes good compasses. Even the ones that I don't like are pretty good by them. And this is one of them. This has a free... Sorry, I need a drink of water. Alright. This has a does not have a free floating bezel. You have to turn it. What that means is if you pull out your compass and you go to get your bearing, okay, cool, we got our bearing, north is that way. That means you have to turn the compass bezel, which has the degrees and the north, to line up, and there's even a little red, in this model, there's a little red arrow inside there. Alright, and there's a red N for north. Alright. On any compass too, like I said, the north is always going to have the arrow, and if there's a different color or a coloration or luminescence that you'll see in another model, it's always going to be on the north arrow. Okay, this obviously is the south arrow. It doesn't have red. Alright, but to gain your bearing with a non-free floating bezel compass, you got to pull it out, let it get steady, hold your compasses level. Alright, and then you have to turn that bezel till the north-seeking arrow matches up. Now the idea, you see this compass has an arrow pointing on it. What that means is when you're standing holding this compass, this should be at your chest. Alright, I'm standing right behind the camera, so imagine you're holding this compass and the camera is you, and you're facing your compass as you're holding it. You want to pull it out and look at it this way and try to get your bearing. Okay, get in the habit of pulling it out and holding it straight in front of you. This one gives a nice little arrow to remind you, hey, hold it the way you're facing, or the way you're going, or the way you're, the way you're, don't, if you think you're supposed to go over here, okay, don't pull your compass out and hold it this way, even if you're facing this way. You hold it the way you're facing it. Okay, that's important for getting your bearing. Because when you walk with the compass and everything, you're going to hold it straight in front of you, pointing the direction you're walking. And the north arrow is going to go north, and you line up that north on the bezel with the north arrow. And now I know I can look down here. This arrow line comes all the way down to the bezel, and I can see that I am actually facing, this compass is facing 30 degrees. Okay, just about 30 degrees. That's actually 30 degrees there, so you're actually about 32 degrees. Okay, north is that way. Now if I wanted to go north, I would turn my whole body to face north, so the north arrow is pointing the direction the compass is facing. Now I know if I start walking that direction, I'll be going north, but we'll talk about that later. Right now it's just an introduction. I'm trying not to get ahead of myself here. Alright, this is another one that does not have a free floating bezel. I do not like this compass. I thought I was going to like it. What this is a very, very cheap knockoff of a very, very expensive compass that I actually like, which is the Silva Ranger, which is made almost exactly the same way, and that's why I figured I'd buy this one and check it out and try it out, because I was hoping it would function in almost the same exact way, but it doesn't exactly. There's slight differences, but that's in material. And this one has a mirror on it. We'll discuss that a little bit later. Discuss those features a little later. That's more advanced uses, but right now we're just going to do an introduction. But on this one here, I'll try to focus. I guess that's the best my camera's going to get. But you can see the little green dots. What this one has luminescence for glowing in the dark, which this one did not have. So you would have to use if you're navigating at night, you would have to use a flashlight. This one has a luminescence. It has, like I said, if it has a luminescence, it's going to have a piece on the tip of the north-seeking arrow. It's not going to have one on the south arrow. The only arrow that's ever going to glow is the north arrow. Okay, so if you ever pick a compass up and you look at it and there's a tip of a needle glowing, that's the north arrow. Always, always, always. And for some reason, some compass has one on the south, don't buy it. Something's wrong with it. Somebody goofed up at the factory. This one has a little dot on the east, south, and west also, so when you're turning it, but it has a double dot on the north. You can see it almost pretty clear in my camera there. This one here is also not a free floating bezel. Okay, you have to turn this one to match it up. And you'll see the reason I don't like this compass is the needle sticks. You have to be almost completely flat for this to work, or otherwise I'm just slightly upturned, and the needle's not moving. That's why I don't like this one. It sticks. But those two double dots that move with the bezel, that's your north. So if you're orientating at night, trying to get your bearing at night, those dots will be glowing. The dot on the north, the two dots. The dot on the north arrow and the two dots in the north bezel ring. And then what you would do is you would turn it until the luminescence on the north arrow is between those two dots, and now you know you're your compass is orientated north, or the bezel ring is orientated north, and that needle is lined up. And as you can see, just like before, this one doesn't have a line like the Polaris does. What this one has is a mirror, and there's a little hairline going up the mirror. You can barely see it in the camera, but the way you would read your direction, if you just didn't, you can look at it and pretty much figure it out. But if you couldn't figure it out, you would look up into this mirror. You would turn this mirror until you could see the bezel ring, and wherever that line was, you're facing that direction. Remember I said you hold the compass facing the direction you're walking, center of your chest, and that line in the mirror would cross over a number in the bezel ring, and that would be the direction you're heading, which is pretty much 32 degrees, just like the other compass was showing. All these other features on the compasses, the two that I've shown so far with the measurements and stuff, that's all for map reading, and that's way later in a couple videos from now. Now this is, my preferred compass is the military issue lensatic compass, and I don't have mine anymore right now, and that is a free floating bezel. Okay, this is a very good imitation of it. It's pretty decent. I have no problems with this compass at all, and this is a free floating bezel. As you can see, when that north arrow moves, the whole entire bezel, there is no, I can turn this, but this isn't the bezel. Okay, this is just two luminescent marks and a magnifying glass that you can use to help navigate with, and we'll discuss that in the future. That's mostly for night and land navigation. But you can see when I turn, the whole entire bezel moves. That means when you have a free floating bezel, you don't have to stop and take the time to wait for your north arrow to stop and make sure you're holding it flat and level and line up the bezel. This one's okay. This Silva is okay doing that. But like I said, with this one, this piece of crap knockoff, you know, that moves and it gets jammed up and the needle gets stuck, you can be sitting there for 15-20 minutes just waiting to get your bearing, your compass orientated. But with this, whenever I pick it up and I hold it to my chest like you're supposed to, facing the direction that I'm walking, just as we are in the camera, it automatically adjusts. In my book, that's the best compass you can get. And these lensatic compasses like this are set up pretty decent. There's a couple different ways of viewing through these and a couple different methods, and we'll discuss that in the next video. But right now, like I said, it's just orientation. So if you're on the market for a compass, a free floating bezel is one of the best, because then you don't have to adjust. You don't have to take the time to adjust the north arrow and all the degrees, and you don't have to take the time to make sure everything's set up right, and you don't have to worry about your needle sticking. You know, if you take one of these and it doesn't move freely, then there's something bad with it. Okay, if that bezel starts getting stuck or it don't move and you gotta shake it or whatnot, okay, that means something bad. The way these are designed is actually, this bezel is actually in water, and you can see that little metal thing. There's a pin, and it sits kind of, I don't know what the technical term is for it, but it balances itself, and the magnetism of the earth and the compass causes it to spin on that little pin, and it balances on to face north. Okay, I'm not going to take my compasses apart to figure it out. So, but and now one more little thing about the compasses, I'll tell you. These two do not have this feature. This only does degrees. Okay. Whereas, you know, the button compasses don't have degrees, just has little tick marks. This one has, alright, well, I can't get a clear shot, but you're just going to have to take my word for it. I'm not going to lie to you. But, yeah, you can kind of see it clear there. Okay. Remember, this has two sets of numbers in it, okay? When we do land navigation, whenever you do land navigation, it's always in degrees, okay? The outer ring is degrees. You can see the north arrow. The north is pointing at 360. Yes, earlier I said north is 0. North is also 360. Why? Because there's 360 degrees in the compass, okay? So 360 is also 0. You start, you count, and you go all the way around. you get to 360, which is also 0. You just automatically start over, okay? So if you were going 360 degrees or you're going 0 degrees, you're going the same exact direction, okay? Now, keep this in mind. Remember this. The outer ring of a compass is always degrees, okay? The inner ring is mils. We do not use mils in lane navigation. Okay, to be honest, mils are there for aviation, it's there for artillery, it's there for engineering. Okay, we do not use mils. When you do lane navigation, when you look at maps, it's all going to be talking about degrees. So never mind this center ring. And if you get confused and you're looking at that center ring and you're like, oh, I can't find 360. It only goes so far. That's because that's the mils you're looking at. Look at the outer ring. Okay? That's the outer ring that you're going to be looking at. Okay?